right, day 1, section 1, geometry, chapter 1. Just going to start by graphing some points. You probably did this maybe, what, 4th, 5th grade? You maybe started graphing some points and went from there. It's very helpful, though, to know that when you graph, this is sometimes called an ordered pair or a coordinate. That x will always come first, followed by y. And that's just because it's alphabetical. That's pretty straightforward. But then it helps to know which axis is which. This is the x-axis, and that is the y-axis. Okay? You can actually graph many different ways. This just happens to be one of them. For example, you could do polar coordinates, which those of you that go on to advanced math will be doing that, and you can create some rather interesting graphs with that. Before we go over to letters D through L over there, let's just make sure that we can get to these particular coordinates. It's pretty straightforward. You're always going to start here, which is sometimes called the origin, or it's point 0, 0, because you're not going to move on the x and you're not going to move on the y. Always do the x first, so if I started here and I had to get to over there, because I'm trying to get to A, for example, maybe those are streets of a city or something like that, I would have to go to the left. Let me see, 1, 2, 3. And so what you do when you list your coordinate is -3, because left and down are going to be your 2 negatives, right and up will be your 2 positives. And if I am now at this location, I still need to go that far to get to my destination. And I went up, well, let's find out how many. 1, 2, 3. So I went up 3. So that ordered pair, or that coordinate, is -3, 3. Okay. Again, the key is to make sure that you do x first. So if I'm getting to B, again, you start at the origin. Don't start from A to get to B, unless A happens to be at the origin. All right? So you start at the origin, you go to the right one and up 1, 2, 3, 4, 5. So that is 1, 5. Is that correct? Yes, it is. Do you have to put those lines in like I did, that blue lines and the green lines? Do you have to put those in there? No. That's just me showing you where it goes. And let's face it, if somebody listens to this recording and I'm just pointing at the smartboard, they probably can't see that. All right? And so I put stuff in there like that so that they can see that. Quite frequently, people get the ones wrong that are on one of the other axes. Maybe it's on the x-axis, maybe it's on the y-axis. They tend to get those wrong. They get them reversed in their mind. I know why, and hopefully we can address that as time goes by. So you start at the origin. Again, don't start at B. Start at the origin, and you go right 1, 2, 3, 4. So I went right 4. Did I go up or down at all? No. So we know a 4 goes in there and a 0 goes in there, but you need to know which one goes where. But I went to the right 4. Remember, you always do x first, which is right or left. And so it is 4, 0. Any questions about that? Okay. I'm going to give you a few seconds here to go ahead and try and graph D through L, and just graph them on this same thing. And what is this whole thing called, by the way? This whole thing has a name. Okay, some of you are going to call it a graph. That's pretty close. It's actually called the coordinate plane. You might want to write that down somewhere. You never know, that might be important. Coordinate plane. Because it's a plane that you put coordinates on. That's why it's called that. So go ahead and try that. I'll walk around and see how you're doing. All right, let's see how you did. Hopefully you did pretty good. We'll find out pretty soon. Yeah, it's not coming out. Oh, it almost did there. All right, be that way. It was working earlier, but apparently it doesn't want to work now. Well, we'll put it in there, I guess. No, I'm too lazy. I'm going to go back to the computer and bring it up. Because I've done them all already, I really don't want to have to do it again. There you go. It was set up to do that earlier, but apparently it didn't feel like it. So there they are. Any observations? Yes. No, it's not. No, it's not. That's 4, 6. Yes. Ah, yes. I was just seeing if you were going to pay attention or just take for granted that you did it right. I will do that a lot. On yours for L, you have 4, -6. I have 4, 6. So technically, is my L in the wrong place? No. And is your L in the wrong place? Hopefully not. Okay? But just keep in mind that on yours, it should be down here at 4, -6, not up where mine is. I will test you a lot. Stay on your toes. Okay? Any questions about graphing? Again, X first, then Y. All right, on the back, unfortunately, the copy did not come through properly. And the copy machine is down today, so that's lots of fun. But once you graphed points in, well, I don't know, maybe 5th grade, then a little bit later you started graphing other things. And we're going to start by graphing some lines here. And so write down this example on the back of your notes. Just write it in there. You won't have to do that too frequently, but in this one you will. And give yourself a nice little XY axis there, and also an XY table, because that's how we're going to tackle this problem today. And for now, you can probably the easiest way to get an XY axis is to just trace the one from the other side. You should be able to see it through your paper. Just kind of go over the X and Y axis. All right, easy enough. Well, again, that would be X and that would be Y. All right. Now, of course, there are many ways of graphing lines, and we'll kind of go through those as the year progresses. But for right now, let's do it this way. Basically, the XY table is helpful, and I strongly recommend that you get at least 3 points when it's a line. The reason I know this is a line is, number one, it says so. And number two, it is y to the first power and x to the first power, and they are not multiplied together. So this will be a line guaranteed. And so basically what we need to do is choose some values for either x or y, substitute them in, and find out what we get in the end. Sounds a lot like some of the worksheets we've been doing lately. All right. And so I, looking at this particular equation, would probably choose to substitute things in for x. The reason I would do that is because once I substitute that in, do the math, I'm given y. You see that? No more algebra is needed. Could I substitute things in for y and then do a bunch of algebra to get x? You could. Is that a smart choice? That's up to you. But I'm going to choose to put things in for x. Because as you will learn soon, mathematicians kind of lazy. We come up with lots of abbreviations and quicker ways of doing things. So what is a good choice for x to substitute in? You could substitute in 100, but probably not the best choice in the world. Choose. Good choice, come on. I think 0 is probably a good place to start. So that means wherever I see an x, I'm going to put a 0. Well, there's an x right there. Put a 0. Again, watch out for those parentheses. You don't want this to look like 20 minus 4. Right? Now you follow your order of operations, which says then to obviously multiply there first. And 2 times 0 is 0. That's why 0 is always such a nice start. So in this case, y would equal -4. Do you agree with that? But y only equals -4 in this particular case when x equals 0. All right. Now when I do lines, I don't necessarily graph as I go. I kind of just get my points and then I put them on there, especially if I know it's a line. For some other things, I'll graph as I go, but not for these. So what is perhaps another good choice? 1, I think that's good. 1's a good choice for 2 reasons. It's close to 0, and it's easy to deal with. So right in here, I'm just going to put 1 instead. And then you just start the math over. You take 2 times 1. Again, same order of operations here. 2 times 1 is 2, minus 4. Now be careful on that one. You can easily get a really weird graph if you do that part wrong. So it's 2 minus 4 is -2. Very good. And how many points did I tell you to get? I said at least 3, especially if you're going to do a line. Yes? Sure, what do you want? 2. All right, that's a good choice. In fact, I looked ahead, and I think 2 is a really, really good choice because of what's going to happen. All right, so I like that one. All right, so you put 2 in. Again, it's close to 1. It's close to my other points. Very smart choice. And this one works out very nice because 2 times 2 is 4. You subtract 4, we get 0. But keep in mind, y is only going to equal 0 in this case when x is 2. So right there, we basically have 3 ordered pairs, or 3 coordinates, that we can put on this coordinate plane. So 0, -4, so should I go right or left at all? No. And then you go down 4 according to this. And then 1, -2. And then 2, 0. There it is. Are those the only 3 answers to that question? Those are not the only three ways to make that equation true. There are a lot of combinations that make that true. In fact, they're right there. Okay. Notice I have an arrow on both ends because it does go on indefinitely. And again, I think it's lost on some of you, because some of you don't like graphing lines, I realize that. But what you've just done is you've shown every possible combination of x and y that makes that original true. Could you have ever really sat here and listed all ordered pairs that make that true? There's no way. You can't. Okay, but somebody says, well, you just do 1 and then you do 2. Yeah, but then you do 8 million. What about 0.1? You're not going to do all of those. So in other words, if I were just to choose this one right there, choose that ordered pair, it's going to make that original true if I put it in for x and y. It's a combination. But what if I put in that point over there? That one over there is not going to work. It's not going to make it true. Okay? So are there any questions on that? All right. A few more vocabulary words you might want to stick on your page somewhere. Okay. Let's get rid of this point right now. On that board, I have 3 green dots. Do you agree that those 3 green dots are on the same line? Yep. There's a name for that. Okay. It's kind of spelled a little weird, but there is a name for that. Collinear. In here, I know it's not English class, but in here, there's going to be a lot of prefixes, a lot of suffixes, and a lot of changing nouns to adjectives. Right? That's just how it's going to be. You might want to get used to breaking down words. Okay? And of course, I'll ask somebody what the root of collinear is, and of course somebody would want to say ear. But it is not ear, it's line. Okay? The AR is added to the end to change that line, which is a noun, into an adjective. It's talking about these points. Really, the prefix here is co, not col. Prefix co, any ideas? Okay, together is pretty good. One that is easy for you is with, because in Spanish, con is with, correct? They all come from the same root of Latin, all right? And so it's basically points that are with the same line, or points on the same line. Do you agree those 4 points are collinear? Okay. Now, I had this other point up here before, and you said, well, it was about there, wasn't it? And you said that point is not a solution to this equation, correct? So what if I take the 4 green we already had and add on that 5th green? Are all 5 of them collinear? Are those other 4 still collinear? But if I ask you to look at all 5, they are not collinear, are they? Okay. So basically what it is it only takes one bad apple for all those points to be considered not collinear, and all you have to do is add another prefix on this word for the next word that means not collinear, and it is non-collinear. Okay? Means not on the same line. Okay? So a double prefix in a way. Okay? Again, I could give you 100 points that are on the same line and give you one that is not. And if I ask you about all 101 together, non-collinear. Obviously, I can give you more than one that are not on the same line, but all I have to do is really give you one that's not. Okay? Do you have any questions on that? On your front side, it has labeled the coordinates for you. Or not the coordinates, the quadrants. This is quadrant 1, 2, 3, 4. Why'd they make that number 1? Why not bottom right? Why couldn't that have been number 1? Any ideas? Yeah. Okay, and what's the significance of it being positive and positive? That's very true. Okay. In math, do you agree we kind of use all 4? Right? But in the sciences, where time is involved, do you normally use all 4 quadrants? In the sciences, say physics, things like that. Not really. Which ones do you use? Both positive, right? Okay. And so basically it's quadrant 1 because it's the most commonly used. And the second most commonly used is quadrant 2. And after that, they figured they had a pattern started, so they might as well just follow it. instead of just start jumping all over the place. Just 1, 2, 3, 4 sounds good. Okay. Any questions on that? So if I were to ask you what quadrant some points are in, you think you could handle that? All right. And of course, this is going to be a little bit of a pain and not do it again. Oh, hey, it worked that time. All right. So how about point I? What quadrant is point I in here? You can just shout it out. 1. All right. Point K. 3. My point L. Your point L. 4. There you go. E. Y-axis. It is not in the quadrant. Good answer. Okay. Or if the question truly says which quadrant is it in, you can say it's not. Okay. Or a better answer is to say y-axis. Okay. A. 2. C. X-axis. Yeah, it's not on a quadrant. And obviously your other example of one that's not in a quadrant is J. Okay. So any questions on quadrants, lines, coordinate plane, collinear, non-collinear, anything like that? Or if I give you a line to graph, getting some points. Okay, the reason I choose 3 is in case you make a mistake with one of them, then of course they will look non-collinear. Any questions? Okay.